Yes, so we can start what we are supposed to do as we wait for others. Today, let me share my screen with you as we continue. Okay, let me expand this one and expand this one also. Okay, I think it's clear now. Today we are going to do something we call data cleaning. And you will bear with me that data cleaning, the first step to analyze data, the first step you have to clean your data so that you may not make wrong inferences. And data cleaning does not have a structured way or structured steps. You say this is step 1, this is step 2. You clean your data according to the interest of the programmer or you the analyst. So you remove everything that you don't want from that particular data before you can start analyzing it. Okay, data cleaning is just a process of fixing or removing incorrect, corrupted, incorrectly formatted, incorrectly data formatted, duplicate, removing duplicate. You remember before in SQL, you cannot analyze data with the duplicate values. And remember the value that we use to detect in duplicate is the unique identifiers. Or the incomplete. What do you mean? I say unique or primary keys, unique identifier or primary keys. Things like ID numbers, for example, the registration numbers of students, all those things. Something that is unique, something that you don't share with anybody. So this is what we call the duplicate. Another thing, you can format or remove the incomplete data within a data set. So when combining multiple data sources, there are many opportunities for data to be duplicated. Sindio, you are combining, for example, table 1, table 2, table 3. There is very high chance of having duplicate data. Now, if data is incorrect, outcomes and algorithms are unreliable because I think you understand how degrees of freedom is of great importance in some tests like the t-test, the chi-squares, all those things. And when you have duplicate data, it means you have more entries than the required entries or than the required data that you actually want to analyze. So you have to do away with those data and have the correct data so that you can have the outcomes that are reliable. Even though they may look, even though this data may look correct, even though the data may look correct, still you will have unreliable what? Outcomes. You cannot make proper decisions, or the decisions that you will make will have a lot of biasness. So there is no process, there is no one absolute way to prescribe the exact step in data cleaning, as I said earlier. So the process becomes this process of data cleaning will vary from data set to data set. But it is crucial to establish a template for your data cleaning process so that you may know who you are doing, what you are doing, whether it's right or wrong at every time. Now, I created a sample data set. I created a sample data frame, to explain or to teach you some methods, the critical methods that are used in data cleaning. And imagine this is like theory. This is like theory. So the process of data cleaning will remain as the way I'm going to teach you today. So because a code that is used to remove empty spaces, for example, empty cells in data sets, will never change. The process of removing null or non-applicable data sets in R will never change. So it's very important that you understand them as earlier as now. Remember the syntax for creating data frame? Now, I decided to use a small sample, a small data frame that you can see what we are doing. And this is the same process that will be applied to a very, very large data set. This is the same method that will be applied to a very large data set. The syntax for creating my data frame is simple, as you can see, so we don't have to go through all these things. Or if you have any question here, you can ask. For example, in my data frame, I have a variable called x1, I have a variable called x1.1, x1.2, x4, and x5. So in x1 we have numbers from 1 to 4, then we have this big number here, then we have 1, then we have null, we have 1, 1, and null. That is values that are contained in x1. x1.1 values from 1 to 5, we have 1, we have not applicable, 1, 1, not applicable. So and we have x1.2, we have letters from letter number 3 up to letter number 3. I'm sure we never touched on letters. Letters here this is a function that stores alphabetical letters and data in alphabetic order. So and when you call a function called letters, you will get letters from A to Z. So that is what is happening here. So I'm calling letters from number 1 to number 3. That is actually A, B, C. Then we have another variable here called XX. We have another variable called here X. We have Y, 3 here. We have X, A. X4, we don't have values. There's an empty space. And X5 is not applicable. So when I execute this command here, yes, so I have the output. I call the output. I think you can see what we have here. We have a data frame. The value of x1, we have values from 1 to 4, then we have a very big number, then we have 1 not applicable, 1 not applicable. So x1.1, we have these numbers here, and x1.2, we have these numbers here. Imagine this is one number, this is xx, this is value A, B, C. Here we have xx, but in with a space. So this is an error, this is a mistake that we assume it's present in our data set, and that's what we want to fix out. We have x, we have y, we have 3 y's, but they have a lot of spaces. So imagine you can't imagine you are in a position where you cannot scroll down the whole data set, so you cannot perform this operation manually. You cannot remove these spaces manually. Yes. We have X, we have A not applicable. So we have X5 not applicable. X5 not applicable. Anybody with the question before we proceed? Any question as we proceed? Okay, I think you know. So yes, Dominic. Dominic Maina, you can unmute your mic. Mr. Dominic Maina. You can unmute your mic, please. Yeah. Okay, let's continue. Now, we want to modify this. For example, the reason why I said we don't have a specific steps for data cleaning is you can either decide to remove these outliers. For example, you can decide to fix this first, or decide to fix these spaces here. You can decide to sort the values that are out of range here, but for this tutorial I decided to modify the column names first. So this is our example 1. So it explains how to clean the column names of a data frame. Let's first have a closer view on the data now. The closer view on our column names, and this is our column names. Remember the syntax for column. You just use the column function. Instead of you use the call name. If you type call names here, if you have call names here, and yes, I'm sure you can see what we have here is the column name x not null, for example, and you can prefer the column that you want to return, but for my case I want to return all the values of x. So x here means the name of the data frame that you want, or the data set that you want to return. So for my case, I apply the column call names data, then you execute the command. We have x1, x1.1, x1.2, x4, and x5. You can modify this data, you can modify these names here. So the default, I used the default call name functions, and let's see. Let's assume that you want to change these column names to consecutive range. This is visible. To consecutive range with the prefix call. Then we can apply the call names and paste the functions, and end call function are shown below. Check here. I want to start my names with end call for consecutive in consecutive order. Check, we have one full colon end call. So my first column will be column 1, then the consecutive one will be call 2, the other one call 3, call 4, up to the final column. And I will ask you, or I will urge you to go and read some, just to do research on the functions of paste this one here, paste 0 here, so paste 0, and you will be able to understand the syntax, or rather the functions of that paste 0. Remember, what do we want to change? We want to change the column names. So we are assigning the call names data. We are assigning now. Check here. We have the call names data. We have x1, x2. Now these values, I'm equating them to the end call from the first one in consecutive order. So when we run this command, what do we have? We have the column 1, column 2, column 3, column 4, and column 5, and column 5. Now, this is the first question for this week, and I decided to give you questions as you read, as you continue. So these questions will probably be in your project. So yes. So this might be your question now. Now I want you to apply this function here, changing from call 1, call 2, call 3, call 4, call 5 to entry 1, entry 2, entry 3, entry 4, entry 5. So yes, that is your first question in this week's project. Let's continue. Okay, let's continue. We want now to deal with empty data, not empty actually, the missing values. We want to deal with missing values. A typical problem for each data preparation is missing values. So if a programmer is not inserting values in your, okay, let me just a problem here, just a minute. Okay, let's continue. We will agree that if you have let's say 5 enumerators or 10, and they are inserting some data in a certain database or in an Excel sheet, there is a very high chance of having empty spaces, or during the data collection process, you may encounter data that is missing. Dominic Maina, nani akaribu na Dominic? Mr. Benson.
Yes.
Uko na namba hiyo mzee?
No.
Sasa tufanyaje? Sababu anasumbua.
Let me take it.
You can mute him.
I can mute him from my side.
Yeah.
How do we mute? How do we mute somebody? How do we mute? Ama nimtoe. How do we mute somebody?
From the chats.
From the chat. Chat with everyone.
Not chat, but the members. The members.
Hiyo icon ya members iko?
Show everyone.
Sure.
The one near the chat box.
Yes, we have members here. Oh, yeah. Nimekumpata. So acha nimtafute pahali yako. Anaitwa Dominic Maina. Dominic Maina, yes.
3 dots. The 3 dots on the end.
Okay. So acha akaive sasa, si ndio? That is it. Let's now continue. So tafadhali get today's content. Naweza waambia aje, this is the first process of analyzing data. So hata ukiambiwa na mzee, hata ukiambia mzee I have done this certificate, I want you to clean data for me, ukienda kumfanyia vitu hazijafanyia data cleaning, you will give wrong inferences. Sasa you will give wrong inferences. Imagine and you have gone into a field for data collection process, and one client designs not to answer a specific question in your questionnaire, so that will be missing, there will be missing values there, sindio? Kwa mwenye sasa anaweka hiyo data in an Excel, so hapo kutakuwa na missing data. Now these missing data now, they are the ones that we want to analyze or to do away with them. How do we replace them, for example? So in our programming language, missing values are usually presented by na. Missing values are presented by na. Are we together? That's why we have under column 5, under column
Sir, you're breaking.
Pardon?
You're breaking.
Sure. Let me check my...
Ama ni side yangu?
Inaweza kuwa ni side yako. Others, mnanipata kweli?
Yes, we can hear you.
Okay, let's continue. And now, hebu angalia hapa kwa makini. In column 4, we have nothing. So these are missing values. We have missing values in column number 4. But in column number 5, we have missing values, but we have replaced them with na, not applicable. I will take you back to our code here. And yes, check here. Under column 4, under variable x4 here, we have nothing inside these braces, but in column 5 we have na. Now we have replaced column 5. Yes, we know it's empty, but we have replaced it with not applicable. Are we together? But in column 4, we haven't replaced that column with anything. So we assume that that column has no records. Now, how do you do analysis with an empty column? How will you make references? For example, you want to compare column 1 and column 4, and now we assume that column 4, let's assume it has some entries, and on other rows there are no values. So that is what we mean there, and we will see how we can do that one. For that reason, now it's useful to convert all missing values to this na format, the not applicable format that we have used on column number 5. In a specific example of data frame, we have the problem that some missing values are present in black character string here. So we don't have those values here. Now we can print all those blank spaces in our RStudio using the data function. I want you to compare these ones here. I want you to take in here. What do we have as our data? First, you have to call your data. So this is our data. But now I want to call data. You remember the use of closed brackets? Use of closed brackets. Closed brackets is used here. Closed bracket is used here to show or to call the subset of a data frame. But for our case, we are calling the whole what? The whole part of data. The whole part of data, which is equal to, we don't give anything here. So, for example, if you give, if you say, for example, I want to call A, where we have A in our data set, now we have all these things here. So, for example, you can call where you have 1 is equals to 1. We have 1 here, we have 1 here, we have another one here, now 1, all these things. So, but now we want to call empty spaces, so we don't have to write anything inside our codes. And when we run the commands, we can see that we have a lot of not applicable in our data set. We have these values here. We have 3 of them here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have another 10 there. Then we have these ones here. I think these are for column 5. These parts. We have this 10 here. We have this 10 here. So we have this 10 here. See there. We have another 9 ukundani. Now, if we want to assign now a value to those blank cells, we can use the following syntax. Check the syntax that we are using here. We are now specifying this part. We are assigning this part with the empty spaces to a logical operator, not a logical operator. This function count not applicable, and you will see when we run the command. Let's say expected in symbol. Yes, you just ignore this area here. Yes, now imekuja. From there, you can check your new data set. We have assigned not applicable to these values here using the equal sign. You can check your new empty values. Let's see whether you have them. Yes. Now, zenye zilikuwa hazina the values inside, now they have been assigned the not applicable value. Remember in column 5, we had already specified this part here, the null, this part here, from the code itself. And let's see. Check. We have this part here. We have them here. That's why we have not. That's why it was being captured inside this part. So the compiler will take not applicable to be an empty space. That's why it's returning empty spaces together with the not applicable values. Let's continue. Another typical problem with missing values is that they also occur in our data sets, is that null values are formatted as the character strings. They are formatted as the character string. Let's have a closer look on column 2. Remember the use of $sign. We are specifying, we are telling our compiler to return only column 2 from the data sets. Remember the name of our data frame is the data. We have column 2. We have 1, 2, 3, 4, 5, 1. We have not applicable. We have 1, 1. We have none. We have none. So. Now, what do you understand by this function here? Not a function, but this is statement. Now values are formatted as the character strings. Remember how we specify the data types in this part? Remember how we specify data types in our programming language? The quotations are used to specify the string characters. No, they are used to specify that this kind of data set is of type string, and values without these marks, opening and closing speech marks here, values that are not in that format, or they are not functions in R, they are integers. So as you can see in the previous output, this output here, the now values in the column are shown between quotes. They are shown between quotes. So they are shown between these quotes. These indicate that those now values are formatted as characters instead of real na values. Instead of real na values. Now, what can we do now to change them? Remember, the syntax must be in na values, not na in quotes. Are we together? The compiler does not understand this na as not applicable parts. It understands only this one. Remember, this is a function inside our programming language. Are we together? R does not understand what's a na that is inside these marks mean. It's you, the programmer, or the data entry clerk, who understands that the na is not applicable. So you can replace now this part. You can replace this part with not applicable. How do we replace values? How do we replace value in our programming language? That is another question. Remember, we are trying to clean this data set. The process of replacing is very simple and straightforward. What you have to do is that you have first of all to specify the column that you want to replace, if not all the data sets, if not all the columns in your data. So for our case here, we have taken values in column 2 in our data. You remember the use of $sign here, but one will ask, why are we having $sign inside here and inside this part? Remember, under data $sign call names, we are taking subset of data with the same entry names, but with accordation, where we have now inside what? Inside these marks, and we assign them to not applicable. Am I too fast? And we assign them to not applicable. I want us we understand this part here. For example, let me call my data set here so that you may understand what we are doing. Okay, I want to replace values in column 2. For example, so I want to return values in column 2. So this column 2 is called data $, column 2. So. But now, what are we replacing? We are replacing that part where we have not applicable in braces. Then we put them to now. Now, this syntax will never change. What will change is the name of data set and the name of the column. Take note. Your point imeenda ikiwa hivi. Hiyo imeenda. Please. What will be changing from now concerning this command here is the data set name and the column name. And if you had if you want to replace anything here to null, the syntax will be the same. So we want to replace null. So we run the command. Let's see. Yes, now we can have the look on our original data set. Remember here we have now, so, but now we have replaced them with na. That is not inside this quote. Check. We have now replaced this part here. So we have replaced na. Remember the first now was in this format here, this part here. But now, at least the compiler can understand what we mean by na, that is inside the quotes. And you can have a view of the column 2. Yes. Check here. This is na. That is not inside what? Inside the quotes. That is not inside the quotes. And the first one here was inside the quotes. Now we have replaced what? Those values. Mpaka hapo. Nani ako na swali wako? Who has question? Who has any question? Benson. Unakamata? Yes, Mary. Mary, how are you?
I'm fine.
Unakamata content, si ndio? Okay, good. Let's continue.
Ndio.
Okay, Mr. Mpuru. Let's continue. Now, we want to remove empty spaces or empty rows and columns. We want to remove empty rows and columns. Imagine, check here, and to demonstrate how to identify delete rows and columns that contain only missing what? Only the missing values. On a side note, example 2 was also important for this step. Since we first formatted now, we formatted now from string to now values. So would not have been recognized by the following count. So that is another step that guided us, or that will help the compiler understand that it's dealing with the original na, the not applicable. So yes. So the syntax below demonstrates how to use the row sum is now function and n column function to remove only not applicable rows. Okay, let's continue. What is the use of is now? Function? So as you remember, I told you that we will not be able to learn all the will not be able to learn all the functions in R. So will not be able. So tukikuta tunaifanya. So what is the use of isna? What is the use of isna? Isna function is used to remove the values with na values. Remember, na is a value by itself. It's recognized as a value by the compiler. They're not applicable. Now, the syntax is simple. We apply inside. Check here. Isna is applied only. Take my point well. Isna is applied only when you specify the entries of your data. The entries of your data. Check here. We have the data. And let's see. This is our data. Isna function is used when you use closed bracket to specify any either column or the whole of your data set. So the syntax is, I want to assign my data. Remember this is we are creating another variable called data. But we have our original data. So my original data here, here, but it's not the one that we are going to assign. What we will get after this operation is performed in this particular data set. So data, then we take the rows. We take what? We take the rows. Isna is.na data. Is.na data is used to return what? Isna is used to delete the not applicable values. Is used to delete not applicable values. So we are expecting, even before we execute this command, we expect any row that has not applicable data equal dropped. Are we together? And the use of exclamation mark here, which is equals to n call, then you specify the data. This part here alone, will tell the compiler, or will direct the compiler to check only under columns, the values in particular columns that coincides. Are we together? The values in columns that coincides with the not applicable values in a specific row. So it means even if you have empty spaces, we have null values in a specific row, and you have only one entry, and you have only one value that is not null in that row, the row will not be dropped. Then the row will not be dropped. Let's see. Then end call. So you have to specify everything inside what? Inside your bracket, inside your closed bracket, and after you specify everything, you give a comma. Then you can run the command and check your original data now. Check your new data. That is it. Check your new data. What are we having? What do we have here? We have values. We have first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. 10th row imekuwa dropped. 10th row imekuwa dropped. So I expect you ask me a question here from this part here. I expect you asking me a question from that part. Ebu angalia hii. Compare this output here and this one here. I expect a question. I'm expecting a question from you. Do you have any question? Okay, let me ask you a question. Na nikiwauliza, I will
Why
say
did it? Sorry.
yes
Why did it drop only row 10
and not row 7.
and not row 7?
Okay. What do you think? Hiyo ndio swali nilikuwa nataka niulize. Why has the command dropped only row 10 and not row 7? Do you have any idea? Other class members? Any idea, guys?
Row 3, column 3, row 7 has value.
Yes.
It's not missing or it's not a null.
Very
And
good.
hence any is applicable.
Yes. Swali imejibiwa mzee.
I think so, but in our syntax,
Uh-huh.
we didn't specify
Uh-huh.
the columns which we are going to be looking at is none.
Okay. We are looking for the whole data set. So
The whole row.
the whole, not the whole row, all rows in your data set.
Okay.
And ukiangalia hapa, the 7th row has an entry on column 3 which is X. Unapata? Unaona hapo kweli?
Yes.
So
Yeah.
our main agenda was to drop a row with all the not applicables in all the number of columns, in all the n calls. I think the point is clear.
It's clear.
Okay, we can continue. So similar to that, we can also exclude columns that contains only null values. Only null values. And remember, if we want to exclude columns that contains only null values, what do we do? We will check the last part here. Instead of having the columns, we will have the rows. See that? We will have the rows. So the one for looking for rows, remember you have to use both the rows and columns. See that? Row sums and column sums. So if you want to start with the rows, you start with the row sums. Huku itakuwa n call. See that? If you want to drop the empty columns, you start with call sums. See that? We have row sums, we have the call sums, and here we have. So the compiler will be checking the columns, but basing its claim on the number of rows. So when we execute this command here, and you can check our original data now. Our original data with our not our original the new data set. We can have now the new data sets with with columns that has values. With the columns that has values. Check here, column 4 has null values, column 5 has null values. Now, I want to ask you a question. What is the difference? Why are we having this signs of less than here and greater than here under column 4, and we don't have them on column 5? Why? Question to the class. Or what is the difference between this na and this na? Moja imewekwa kwa inside this marks here and ingine iko empty, ingine imesimama tu. What is the difference? I want to hear from you.
You have the quotation mark the one.
Eh?
Just trying.
Just try.
Yeah.
Ebu sema sijasikia. Okay. This is the reason. You'll agree with me that the null values with replacements are the ones that are inside this marks. So then you may replace those zinakuja kwa hizi marks. So usikuwa confused why is this null ziko na marks, hizi zingine hazina. That is the reason. Example 4. We want to remove rows. Remove rows with missing values. In this example, I will explain how to delete all rows. With at least one null value. So, let me take an example of for job applications. Where you are told that attach or upload all the documents. If not, your application will be unsuccessful. So as a data analyst, so I assume that you have uploaded every document or every entry that you are required to fill somewhere, and you have uploaded them to the system of the company. I take that particular data, I want to tunaitanga kupepeta. I want to sort it out. I want to remove unqualified. So the first step was to fill all the blank spaces, and you failed to fill one. So the first thing to do, I will omit every record that has null value. Are we together? I will delete every record that has missing values. And the syntax is simple. Now we are not going to use is now. We are going to omit now. We are going to omit now. To omit the not applicable. The syntax is simple. So we apply data is equals to na.omit data. Na.omit data. So I expect now my new data is this one here. So I'm expecting to do away with any record that has null value. And for my case here, we have column 7. But now we are imagining you have an entry that has million rows. So always you can find your manual. So for this part here, I can go and delete it manually. But now I want to delete it using commands, so that because this is the same command that I will be using, to clean very large data sets that I obtain from databases. Let's see. So the syntax is data is equals to na.omit anything inside the data, na.omit the data. Let's see. So you execute that part here, then you call your original data set. So we have from row 5, row 6, we have row 8 and row 9. We don't have row 7. We don't have the row 7. We don't have the row 7. We can now check on removal of duplicate. We can check on removal of duplicate. Okay, before we continue, how do you recognize, or which method can one use to recognize and duplicate value? To say even in Excel or anywhere. What can you see? Which variable can you see and say you have duplicate? I want to hear from you. I want to hear from you.
The last two rows.
The last two rows. Let's see. The last two rows. Okay. So, assume that, let me give you a scenario. Assume that you have data from KU database, data for students only, a table containing student details. What can you use to check if you have duplicates in that particular data? That's my question.
We may check the registration numbers because they must be unique.
We may check the
registration numbers because they must be unique.
They are unique. Actually, that's the correct answer. We check the unique identifiers of datasets. Let's say the primary keys. Can primary keys have duplicates? I think no. For example, you may specify ID numbers of students to be your primary key or to be your unique identifier. So that can be primary key. Now, you will check if you have any duplicate records under that column of the ID numbers or the registration numbers for your case. So if you encounter any duplicate in that particular column, definitely even the other records will be the same for the two entries. Are we together? Are we together, guys?
Yes.
Yes, that is it. Now, how do we remove these duplicates? The syntax is very simple. Imagine it away change itakaa tu. And in this example, I will just demonstrate how to keep only unique rows in a data set. Now I don't want duplicates, I want only the unique rows. So for this task, we can apply the unique function to our data frame as demonstrated in the following snippet. Check here. We have unique data. So for my case here, sikukuwa na kitu kama how do we call them? sikukuwa na, for example ID number, sikukuwa nimespecify the keys yenye naweza tumia, so I just called the unique part. Remember, you can have data that has duplicate, but you haven't specified what the keys that you want to use in your entry. Now hata ukiangalia hivi, which rows are duplicate, I can see that row number 8 and row number 9 are the same. See there? Row number 8 and row number 9. Under call 1 we have 1, call 2 we have 1, call 3 we have A.
Row number 1 too.
Row number 1.
The row number 1, yes, row number 1. So which is duplicate from the other. Now I can use the unique function now to return only the unique values. So I expect to have only one of those rows present in my data. See there? In my data. So we don't have row 8 and row 9. We only have row 1. See there? Ni gani ilikuja ya kwanza? It's row 1. So my compiler has submitted row 8 and row 9. Row 8 and row 9. So row 8 and row 9. I want you now. This is your second question. I want you to check for duplicate, basing your claim on column 1. So I want you to use column 1 as the reference column or as your primary key. So if you have the same entry or the same number under column 1, your compiler will be treating those entries as duplicate and delete the whole row, na inabaki na 1 row, for example na 1 row. So sababu you can have the same ID number, you can if I say use the ID number, you can have the same ID number but have different names. You see, there different names is ukora. Are we together? Yes. It's like telling your compiler, if column 1 has 2 1s, just take one entry by randomly so that you can not include biasness. So question 2 is apply what? Applying duplicate? No, not apply. Removing duplicate. Removing duplicates based on one entry. So yes, that is your second question. So this is done as B. So we have removed the last 2 rows from our data since they are duplicates to the first row, since they are duplicate to the first row. So they are duplicate to the first row. Now we can modify classes of columns. The other day we were doing classes and attributes, and now the class of the column of a data frame is another critical topic when it comes to data cleaning. This example explains how how to format each column to the most appropriate data type automatically. Let's first check the current classes of our data frame column. Here we use the supply function. We always use the supply function to perform that particular operation. We supply data, then we specify the classes. Whether character, integer, all those things. So we have column 1 as numbers, we have numerics. We have column 2 as character type. We have column 3 as character. Now, you can change these classes. For example, this one to be character, the other one to be the integer or those things. And we will the first variable column 1 is numeric, and the column 2 and 3 are characters. Now we can use the type.convert function to change the column classes whenever it is appropriate if we want. Check. This is data. We specify that. We specify the source of data type, the source non data type. We specify the data set name. Then we set the as this function to specify or to give the logical operation. I want to give this the logical operations here to be true if I want to reset from numerics to characters. Yes, check. If we execute this command here and have our data there, yes, you can see we have them. So the output of the previous syntax is when in table, that's previous table 8. Visually there is no difference. Out on a difference unless you execute what? You execute this command here for the supply, so that you can see the difference. However, if we print the data type of our column once again, we can see that the first 2 columns have been changed to the integers classes. The character classes was retained for the band column. Let's see. We have our integer here, we have our integer here, and the other one is class. So this type here, this operation on changing the classes of data is not more common when doing data analysis, because you will have inserted your data first. Because I don't expect you insert integer values and change it data type to character, it does not make sense. This is just a theory. We can check on how we can remove an outlier. For example, if we check on our column 1, we have values 1, 2, 3, 4, 99,000, and then 1. You can say, or we can say, that what we have here is, this is an outlier. It's not this outlier from the value that are forming our column 1. That is an outlier. So that's an outlier. And we always remove these outliers using the box plot. Remember the use of box plot? Box plot is used to show or to tell where your data is concentrated more. So in this example, I will demonstrate how to detect and delete these outliers. Please note, outlier deletion is another very controversial topic. Please verify that it is justified to extract the outliers from your data frame. from your data frame. Please have a look at the outlier removal guidelines here. However, one method to detect outlier is provided by the box plot statistics function, and the following R code will demonstrate how to test for an outlier in our data frame on column number 1. And remember, you can do this in all your columns. For example, column 1, column 2, so yes. So we use the box plot statistics, and this box plot statistic will identify an outlier in a specific column. The syntax is simple. We want to return from column 1 in our data. From column 1 in our data, you remember the use of percentage in percentage. Percentage in percentage is, we said, is used to return dimensions or length of data frame regardless of what? Regardless of the places where the values are in. We are applying now the column 1, the values on column 1 from our data in this statistic of box plot, and this is column 1 from our data. Then we remove or we pop it out, and when you execute this command here, what you're getting is a value that is outside the range of our data in that particular column. Now, in the previous output, as it returned an outlier, as we have seen here. So this value is obviously much higher than the other values in this column. Sindio? I think hata nyinyi mnaona hiyo ni value kubwa sana. You can't compare values that are ranging from 1 to 4. You compare it with 13,000, with the 99,000 and something. So yes, you cannot compare the two. You cannot compare the two. Now, let's assume that we have confirmed theoretically that the observations containing this outlier should be removed. We can apply the following R code below to remove that part. Check. This is just a theory. This is a command theory. It will never change. What will be changing is the name of the data set name, and the columns, and the column name. I want you to compare these two parts here. Okay, I want you to compare these two parts here. And when the programming is very simple. Check these two parts here. What is the difference between code in number 179 and 188? What is the difference between the two? What is the difference? Nataka wenye macho kuangalia vizuri. What is the difference?
I think it's the opposite of one another, because the the not sign gives us the opposite of the first quadrant.
It's opposite. What shows you or what tells you that it's opposite? Yes,
The
I
not
want to know.
opposite.
What?
I'm noting that one is a reassignment. The second statement is a reassignment. Having restated something. So the other one is just a display of an item.
Okay. I want you to tell me the use of this sign here, because this is the difference. You have sign here and a comma here, and you don't have them in this part here. What is the use of exclamation mark? Na kuna pali tumekuwa na exclamation mark tena, si ndio? Acha nionyeshe. Ilikuwa wapi? Yes, check here. Check here. On code number 106, line 106. We used the exclamation mark here and comma here. I want you to connect the two. Exclamation mark in R programming language is used to return. How can I put it? Exclamation mark is used or will trigger the compiler to return the output apart from the ones that you are specifying here. So. And that's why for our case here, let's see. That's why for our case here, yes, we don't. First of all, we have returned the value. So we have returned the value using this command here. And right now what I want to do is to delete the column which contains that particular value. So I use the exclamation mark here and comma here. So I'm directing my compiler to return all the values apart from this one, apart from the ones that are returned by this particular command. So that's the use of exclamation mark. So some syntax, kuna syntax zingine zinatumia the exclamation mark ikiwa huku and the comma ikiwa huku, na kuna the other one, kuna ingine inaitwa sounded that niliona inatumia huku katikati. So ukiona exclamation mark, you are returning something that is opposite what the command is returning, the command yenye imeandika hapo. So yeah. So when I execute this command here and run the command, you will note that we don't have that row. We don't have the row which end what? Which end or which contained the outlier. Which contains the outlier. Now we are we together up to that point? What is remaining now in our data set? Tulikuwa tunajaribu ku clean. So we are cleaning, we have cleaned it up to this point. What else is remaining is removing these spaces. What is remaining is just remove the spaces. Let's remove the spaces. in character strings. And manipulation of character strings is another important aspect of the data cleaning process. So this example will demonstrate how to avoid these blank spaces that are in between values in column 3. We have a space here, we have spaces inside here, but now for our case, we assume that we have a very large data set. We have a very large data set that you can't browse one by one. That you can't browse one by one. Let's see. So this example will demonstrate how to avoid these blank spaces in the character string. And for this task, we can use the gsub function. What is the use of gsub function? What is the use of gsub function? I want one of you to tell me. Mwenye the good student ni mwenye anakuanga mbele ya mwenye anamfunza, si ndio? Who can tell us? Who can tell us the use of gsub?
I think it removes the spaces, the white spaces, the blank spaces in a string.
Very good. Another one. Another. Another one. I want to hear from you. Okay, actually that's the answer. And gsub is used together with another function called sub. So the sub and the gsub function in our programming language is used to substitute the string or the character in a vector. It's used to substitute the string or character in a vector or a data frame with a specific string, for example. So the function are useful when performing changes on large dataset, But now, replacement of character for our case, we are not going to replace only characters. We are going to replace even the empty spaces. Remember, these empty spaces are inside character strings. Or inside character strings. That's why we are using the space here and another space here, another small space here from a specific column. Yes. So the syntax is very simple. You specify let's see, you first of all specify the syntax. So you can have your data here. and equate them to let's use this part here and replace the gsub. So from gsub function, what we are getting even before you finish or before you insert the bracket, from gsub you have to specify the pattern that you want to replace. You have to specify the pattern that you want to replace. Then what are we replacing with? We are replacing with a certain value or a certain anything that you want to replace with. Then from that part now you specify the column or the whole of your data. So the whole of your data. For example, you can see here we have a space on column 3. We have another big space here. We have another space here. Now you can replace these spaces with by deleting that part, or let's suppose you want to replace with a letter. For example, replace with the 0. Replace it with the 0. Let's see what will happen. So even before you execute the command, we expect to see zeros inside those parts. See there? Yes, you expect to get these zeros inside there. But we want now those spaces to be, for example, if you have those spaces like that, they will still remain to be on that point, but now I want to delete them. And before I delete them, okay, I want to replace now zeros with the space in column 3. Unapata venye kunaenda hapa. Yes, si unaona tumekuwa na the original data. But now let me replace those let me delete those spaces, and this is data in column 3. Data in column 3. I want to equate with gsub. Then what are we gsubbing? We are gsubbing this part here, and we are applying what? We are applying that part here, and this is data in column 3. Data in column 3. Let's see. Kama zitakuwa deleted, then you can call. So you can see we have deleted all those spaces that were inside these letters. The spaces that were inside these letters. Okay, the other part here was that I prepared for use for combining categories.
Question.
Yes.
So, for example, in our original data, before replacing the spaces, the last value in column 3, it had the spaces before the first y.
The spaces.
That is the leading space. So what if you want to remove only the leading space in the last value in column 3 here?
The last value in column 3
had the leading spaces.
There are 3 spaces.
It had 3 spaces before the first y. So what if you want to remove only the first 3 spaces before the first y and the other spaces between the y's to remain spaces?
let me check how we can do it. And let me see. Let me see. We have removed this part. Let me see how we can do it. So we remove one part, we remain the other part with the space. Okay, honestly, I have never handled with such a situation. Such cases, I don't think whether they appear. So I will check and research on the same. So
It's okay. I will do it because I've been using that technique in SAS.
oh yeah. So no, the last part was on a combination of categories or combining different categories. And this example shows how to merge certain categories of a categorical variable. So the following R codes will illustrate how to group the categories A, B, and C in a single category called A. Consider the R syntax below. We have data from column 3. We have the data from column 3 here. And then we will use our closed bracket to pick the data that you want. So the data that you want. So we want column 3. We want column 3 from our data. And this is the length of a certain variable regardless of their dimensions. So this is percentage in percentage. Length of column 3 regardless of their dimensions. Regardless of the dimensions they are in. We are picking A. We are picking A, and we are picking C, the B, C and B in column 3. Check in column 3. I'm merging more than one, so I can, for example, I can merge when you are analyzing geographical data. So you can merge Isili, for example, Kamukunji, all to be in Nairobi. So you can merge Likoni, Bamburi, all to be equivalent to Mombasa. So that's what we are talking about. But now we are merging in a specific column. We are merging in a specific column. This is column 3. We have values A, B, C. We have XX, we have YY. I want now to merge B and C to be equal to A. B and C to be equal to A. You can even combine XX to be equal to A. So the syntax is very simple here. We can run the command and see what is happening. And call our original, call the new data set, and you will note that after assigning these values, after assigning this part here from this part up to this part there, we have assigned them to A. So now we have assigned that part A, and we have called that function now. We have called that function where we will have column 3, where we had C, we have A, when we had B, we have also A. We have also A. That was the last example now on what we were supposed to cover today. Do you have any question? Any question from you? Any question from you guys? Lisa, how are you? And Scholar,
Yes, sir.
umetulia sana.
I have a question.
Yes, Mr. Morris.
Though it's not a part of what you have covered, but it's just a general question about R.
Yes.
So I tried to create a classification algorithm. I use the dataset Iris to classify the species, and I tried to create also a GUI using Shiny app, and to in order to capture the user inputs and to predict the species using the R codes, which I coded to classify Iris dataset using the Iris dataset, that is. So my question is now, because Shiny app is just for web development using R code. But my question is, what about if maybe I have a website designed with Python or a PHP, and I want to embed some statistics using R? Is it possible?
Okay. Mr. Morris, I personally am a statistician, so. And I am 100% sure that R script is used in web development where you want to insert statistics. It's used in apps. I had a friend who was applying R in his project, the Fourier project, alikuwa na develop web. So he was integrating the app on time series, ile time ya corona, the app on time series, and the cases. So the app will project the possible cases, let's say ahead by 2 weeks or 3 weeks, but it was using the packages of R. Are you getting me? So it's possible, but maybe I'm a data analyst. So stories za web zinanipiduka kidogo. I think you understand.
It's okay. Maybe I can ask you this, because R can also put a web app using Shiny or another R package.
Yes.
But what if maybe using maybe you are a data analyst.
Yes.
And you have been employed in an organization which uses maybe software which was built in C++ or any other language apart from R.
Yes.
And you have to integrate your data analyst part in that software maybe.
Mm-hmm.
How will you integrate that?
Okay. This is not a matter of thinking, but it's an experience. I had such experience from an hospital called Dumia Friends Hospital in Vika County. They were developing their systems, so they called an IT guy to develop. So they end walikuwa wazee watatu. Kulikuwa na engineer, kulikuwa na IT guys, na yule mwingine alikuwa mgani. Kuna another was sijui warehouse architect, something of kind. Unanipata? But now the system yenye walikuwa wanataka kuunda ni ya hospitali, and where you insert the values of penye unaandika dawa, the quotations pops out, then the system itself does calculations of those medications, for example, and inakupea the final output. So then inside that package, inside their system, they were developing a subsystem of analysis of the clinical trial analysis, and there were some algorithms that they were using. They were using the Fibonacci algorithms, and they were 3. There are some trials that use specific patterns, and
Yes.
now this part of algorithms or the patterns that the trials will use, tulikuwa tunaziandika in R language, unapata. But now my task nilikuwa nimeandikiwa as a 1-page document. Ilikuwa 2 pages zinaonyesha how hizo bacteria zinabehave, hizo unaelewa, hizo mastori za clinics, and walikuwa wanataka the algorithm yenye ikikuwa implemented, yenye ikiraniwa tu kwa hiyo system, it's possible to predict the outcome of the behavior of bacteria, vitu kama hizo. So this Fibonacci algorithm pattern, we were implementing it, but I was told to give the system architect how he can code, how he can apply that coding to a system. So we used the because inaitwa HTML, vitu kama hizo. So tukaandika code in R programming language, so the system employed or used some part of R programming language. But now for those R programming parts, I was there to employ or to deploy those changes, or to produce, to give the correct icons. So they were just clicking some main pops out. I was able to write the cons correctly, and zinakuwa captured in hiyo inaitwa sijui ni PHP. Hiyo inaandika manamba zinakaa aje, unazielewa. And the system worked out. Now, in a matter of creating a database or a system that employs or that uses statistics, I'm sure as a statistician you can't do it alone. You will have to have a team. Sababu for me, PHP hizo za kuunda the system, I'm not familiar with those parts. But they will require some statistics, or the programming part of statistics for their website or their systems to work out. That's now when they will need my knowledge. So that's how we managed to produce or to come up with a system, and it was successful. So yeah, that is it. So anything is possible. Ukiwa mtu
Yeah, so
engineering,
maybe what I've understood from you, maybe it's For data analyst,
Mhm.
you maybe the task is just to develop the algorithm, then you give to another one to deploy.
Yes, yes,
That is maybe data engineer.
yes, vitu kama hizo hasa.
So,
Yeah. So any other question?
thank you.
Yeah, welcome, Maurice. Any other question? Any other question? Okay, Mr. Morris, I think hukukuwa time ya tulianzia, you are not present. Unaona kwa database, nataka kukupea scenario ya leo. So today I posted on the program, we were to start class on 64th, si ndio?
Yeah.
Kuna hospitali kwa pahali walikuwa wamenitia kazi na si eti wako na hiyo ya nini ya inaitwa the SQL. SQL yao, system yao inatumia SQL, system ya hospitali inaitwa Guardian Hospital, iko sendi za Mary. So hao wazee, their system ikakuwa ina fail sana, so ikisavu around 50 patients inakuwa down, so inakuwa you can't, haiwezi kaendelea kuserve the customers. So hii their system, it was designed in a matter that the IT guy mwenye alikuwa hapo hakuwa able to, how do we call it, to clear the cache memory of the system, unapata?
Yes.
Yani kuifanya ikuwe in optimum performance all the time. So that was the reason for the failure of that particular system. And nataka upate this point clear. They had an IT guy who is their system admin. Jamaa anajua ako na experience ya 5 years, but he cannot optimize a server yenye inashikilia hiyo system ya hiyo hospitali, unapata? So kwenda nikaona the architecture ya hiyo system yenye walikuwa wanatumia SQL, unapata they have some records as their system ilikuwa optimized for almost the previous 21 days. Unaona ile kukimbia the cache memory haifanyangi, utaona tu you will stand the methods of optimizing an SQL server. So nikaenda tukai-optimize vizuri, nikamaliza venye alikuwa anafanya. So huyu mzee, he can design a system, he can design this system si ndio?
Yeah.
But ajui the SQL language. Unaona sasa what is happening? He doesn't
Yes.
understand the syntax for the SQL. So remember, for SQL needs kuandika commands to. But the same guy is in the position of developing this kind of system. So tukaenda tuka-optimize the system vizuri, nikamaliza venye atakuwa anafanya, and the day ended there. Ndio maana nikirudi kwa nyumba nilikuwa naenda na speed ingine mbaya sana. Nilitoka hapo at 610 nikaenda almost 40 kilometers from that hospital ndio nifike kwa nyumba. So nilikuwa naenda na speed ingine kwa few sana, but I managed to start the class early. So for vitu zingine lazima tu mkuwe in a team so that zikuwe muweze kukua able to